Good morning student, myself Rajesh from the Department of BCom International Accounting and Finance. Today's topic is properties of arithmetic mean. Properties of arithmetic mean. What is arithmetic mean? A single representative figure for a given mass of unwieldy data. A single representative figure for a given mass of unwieldy data. Unwieldy data means data can be any manner. Data can be any manner. Or sum of the observations is divided by the total number of observations. This is the general definition. Arithmetic means general definition. Sum of the observations is divided by the total number of observations. Total number of observations is denoted by small m. Total number of observations is denoted by small m. First property. If all the observations of a variable takes the same constant value k, then the arithmetic mean is k. X is a variable. X is a variable. If all the observations of a variable takes the same constant value k, then the arithmetic mean is k. For example, x bar formula summation x by n. Summation x by n. Summation x means sum of the observations. K plus k by number of observations 3. 1, 2, 3. Number of observations 3. K plus k is 3k by number of observations 3. 3 cancel. The answer is k. If all the observations of a variable takes the same constant value k, then the arithmetic mean is k. Arithmetic mean is denoted by x bar. Arithmetic mean is denoted by x bar. Arithmetic mean is also known as mean or average or simple mean or simple average. Second property. The sum of the deviations is 0 when the deviations are taken from arithmetic mean. Symbolically, the sum of the deviations is 0 when the deviations are taken from arithmetic mean. Symbolically, summation x minus x bar equal to 0. Summation x minus x bar equal to 0. For example, 10, 20, 30. 10, 20, 30. This is the individual series. In individual series, only variables are given. This is marks. X is a marks. In individual series, only variables are given. X bar formula summation x by n. Summation x by n. Summation x 60. Summation x is 60. X minus x bar. X minus x bar. Summation x is 60 by number of observations 3. 60 by 3 is 20. 60 by 3 is 20. Next, x minus x bar. X minus x bar. X bar value 20. X value is different, x bar value fixed. First x value is 10. 10 minus 20 is minus 10. Next x value is 20. 20 minus 20 is 0. Next x value is 30. 30 minus 20 is 10. Summation x minus x bar equal to minus 10 plus 10 cancel. Answer 0. The sum of the deviations is 0 when the deviations are taken from arithmetic mean. This is the second property. Next, third property. The sum of the squares of the deviations is minimum. The sum of the squares of the deviations is minimum when the deviations are taken from arithmetic mean. Symbolically, summation x minus x bar whole square is minimum. Summation x minus x bar whole square is minimum. The sum of the squares of the deviations is minimum when the deviations are taken from arithmetic mean. Compared to median and mode. Compared to median and mode. The sum of the squares of the deviations is minimum when the deviations are taken from arithmetic mean compared to median and mode. Compared to median and mode. Next, fourth property. If the mean of n observations is x bar, if the mean of n observations is x bar and each observation is increased by a, then the new mean is x bar plus a. Then the new mean is x bar plus a. For example, this is the original data. Mean is summation x by n 60 by 3 20. This is the original mean. If the mean of 3 observations is 60, if the mean of 3 observations is 60 and each observation is increased by 2. If the mean of 3 observations is 20, 3 observations is 20 and each observation is increased by 2, then the new mean is, for example, this is original data, mu x increased by 2, 10 plus 2 is 12, next 20 plus 2 is 22, 30 plus 2 is 32. This is new data. Mean value summation x equal to 66. 66. Mean 66 by 3 is 22. This is the new mean. So original mean is 20. 20 plus 2 is 22. No need to calculate here. Original mean is 20. So increased by 2. 20 plus 2 is 22. 20 plus 2 is 22. If the mean of an observation is x bar and each observation is increased by a, then the new mean is x bar plus a. Original mean is 20. 20 plus 2 is 22. 20 plus 2 is 22. Next. If the mean of, next property, if the mean of an observations is x bar, if the mean of an observation is x bar and each observation is decreased by a, and each observation is decreased by a, then the new mean is x bar minus a. X bar minus a. The original mean is 20. 20 minus 2 is 18. 20 minus 2 is 18. For example, the original data is 10, 20, 30. 10 minus 2 is 8. 20 minus 2, 18. 30 minus 2, 28. Summation x. 54. Mean formula summation x by n. Summation x is 54. 54 by 3, 18. If the mean of an observation is x bar and each observation is decreased by a, then the new mean is x bar minus a. Next, if the mean of an observation is x bar and each observation is multiplied by p, and each observation is multiplied by p, where p is not equals to 0, where p is not equals to 0, then the new mean is x bar into p or p into x bar, 2 into 3 or 3 into 2, so x bar into p or p into x bar. For example, each observation is multiplied by 2, each observation is multiplied by 2, here original mean is 20, 20 into 2 is 40. 20 into 2 is 40. For example, multiply by 2, 10 into 2, 20, 20 into 2, 40, 30 into 2, 60, summation x, 120, summation x, 120, summation x, 120, 120 by 10 into 2, 20 into 2, 30 into 2, 3, 40. 40. That's the mean. 40. Next, if the mean of an observation is x bar and each observation is divided by p, and each observation is divided by p where p is not equals to 0, then the new mean is x bar by p. Then the new mean is x bar by p. For example, divided by 2. Divided by 2. The original mean is 20. 20 by 2 is 10. 20 by 2 is 10. Original data 10 by 2 divided by 2, each observation is divided by 2, 10 by 2 5, 20 by 2 10, 30 by 2 15, summation x 30, summation x 30, 30 by 3 is 10, 30 by 3 is 10. These are the properties of arithmetic mean. Thank you, students.